This video introduces you to the actual calculations for a gradually varied flow profile. The knowledge you have gained from previous lessons on open channel flow are essential. The following are general rules that one must remember as we construct water surface profiles. First, gradually varied flow and rapidly varied flow are the lines indicating the actual water surface. The depth of flow for gradually varied flow is gradual, as indicated in its name, and for rapidly varied flow, it's rapid or quick and occurs in a short distance. One must always be able to identify points of control, POCs. For example, locations of points of control can occur where we know the water surface elevation, such as at a hydraulic structure, a known critical depth, or normal depth. Finally, the depth of flow is constant until the depth of flow is constantly changing. It's not constant. It becomes constant once it hits normal depth. Thus, remember to always refer to the water surface profile shown in our previous lessons. As you may recall, M1, M2, M3, S1, S2, S3, and so on. As we perform gradually varied flow profile calculations, the following general assumptions are used. The energy equation, or the specific energy equation, is the depth of flow plus the velocity head. The flow is steady flow, meaning a constant flow rate is moving through the channel. The channel is defined as being prismatic, which means the shape of the channel does not change, the cross-sectional shape. Therefore, it's always rectangular with a base width of 10, or it's trapezoidal with a specific side slope and base width. The velocity distribution within the cross-section is constant, and the roughness is constant as well. When qualitatively calculating water surface profiles, remember to, again, always pull out your gradually varied flow profile shapes. Remember the following things. When you're identifying controls, if the flow is subcritical, you must know the downstream control. And if it's supercritical, you must have an upstream control. Many times, before you perform any calculations, you're unaware if the channel will be subcritical or supercritical. So it's important to understand the boundaries at both extremes of your project. Second, if you have critical depth control, this occurs at a free fall, as shown in the schematic. Or it can also occur when a channel changes shape from a mild to a steep slope. Third, you may need to have a known water surface elevation at a hydraulic structure. So when you know all these things, you can be given a channel. If you know the normal and critical depth, you can identify if it's mild or steep, horizontal, critical, or adverse. And you can then create a sketch qualitatively of your expected water surface profiles. We will practice this in class, but this general knowledge of our controls, what critical control is, and what's a known water surface is important. Next, we are going to perform qualitative water surface profile calculations. In order to perform qualitative profile conditions, you need to remember the lessons from prior of calculating the normal and critical depth. This is important to identify the channel types. Next, we're going to use a qualitative approach and sketch the expected water surface profiles based on the rules mentioned in the previous slide. Once we are there, we're ready to start calculation of our gradually varied flow profile. The gradually varied flow profile length is defined by the change in energy over the change in bed slope minus the change in friction slope. Now, how do we calculate our terms? The friction slope is an average friction slope between the upstream and downstream point. The friction slope is calculated by rearranging the Manning's equation as shown. And the energy is calculated using the specific energy equation. What one must realize is that if you do not take small increments of depth as you are calculating the length of the profile, you will get a very inappropriate length, and we will discuss this in class as we do more and more examples. So we choose small increments of depth. Then we'll calculate all our parameters: the velocity, the hydraulic radius, the friction slope, the upstream and downstream energy, and then finally we'll calculate the length. Once we have lengths for all our small incremental locations, we could sum it to calculate the total length for that reach, which represents the gradually varied flow profile for that channel. So again, as I mentioned, we will do examples in class that will help solidify the calculations of all these equations. But again, please remember to have the equations written down and you understand what you're looking for, so that we can spend the time analyzing the calculation steps and not concentrating on the equations.